Hello there. Welcome to CXC Math TV. And today we're going to be looking at bar charts. We're going to be looking at how to analyze and interpret bar charts as well as constructing a bar chart. So the first thing is, what is this bar chart? Bar chart, this is a chart that's going to display the information presented from a frequency table, either vertically or horizontally. And this is how the bar chart usually look, right? Vertical bar chart graph, or it can be a horizontal bar chart graph. Now, it doesn't matter which one of these we're gonna use, right? It doesn't matter, but let's look at how do we go about constructing these bar charts, right? So the first thing to do is to create a bar chart, we need to put the independent variable on the x-axis with equal width and the frequency on the y-axis. That is all. From your frequency table, all you're going to do is put the independent variable on your x-axis and the frequency on your y-axis. Now the length of each bar goes up to its corresponding frequency value. Best way to do it is with an example. For example, look at this question. Mr. Ferguson had asked his students what is their favorite sport. The table below outlines the results. Create a bar chart to compare the students' favorite sport. 6% in the class say cricket, 13% say track and field, 13% says football, 9% says track and field, 3% says basketball, and 1% says hockey. So the first thing is, notice they already labeled the y-axis for us. And on the y-axis, we know this is our frequency. And on the x-axis, right, we know that is going to be the favorite sport, right? Notice the first sport, the frequency was 6. So we draw a bar going up to 6, and then we'll put the sport name. That was cricket. The next sport is football. So we draw a bar going up to 13, because that's the frequency, and we'll label it football. Then we do what next? Draw a bar going up to 9, and we label it track and field. Draw a bar up to 3, and we label it basketball. Then we draw a bar, just 1, and we label it hockey. Notice, however, we maintain the equal spacing in between each, right? One space we use in between each, right? And that's important as well for it to be a bar chart, all right? There's equal spacing in between each. That's your bar chart. Finally, you can just put your title. So the title is bar chart showing students' favorite sports. Let's do another example. I want you to pause the video and answer this question. Mr. Ferguson wrote down the grades of all students, placed them in categories A to F. The table below outlines the results, right? All the students in the school, right? Seems like it's for math. Go ahead, pause the video and do this question. First thing is grade A. We notice is 80%, so we can draw a bar going up to 80, right? First thing at this time, I'll put my title, bar chart showing students' grade, 80% for grade A. Next thing is, let's give it, a space now, and then the next bar will go up to what, 120. That's B. With a space, then the next bar go up to 200, and then label it C. Next bar go up to what, 100. Then we go, notice 100, we'll label it D. The next bar go up to 40, then we'll label it E. And then the next bar go up to 20, and we'll label it F. And that is it. All right. Now that we finish that part, that's easy, right? Another example. This now is a dual bar chart. Yes, a dual bar chart. Think about it. It says the table below shows the number of tea and coffee students purchased throughout the week at Jamaica College for breakfast, right? Create a dual bar chart to represent this information. Pause the video and attempt the question. Now I know this question might be challenging, and you might be tempted to think it's challenging, but it's not. Now, first thing, dual. So you're going to need 2 bars to represent each of the data, right? So for first thing, we'll put our title, bar chart showing students' daily purchase of tea and coffee. First thing we know is that on Mondays, we know you either purchase tea or coffee. So we're going to have 2 bars for Monday. So we'll put Monday, we're going to have 2 bar. 1 bar go up to 140, one go up to 70. But we need to differentiate which bar is for tea and which bar is for coffee. So we're going to use now different colors. So look, we're going to have a key. We're going to let the yellow be tea and the red be coffee. So the yellow bar go up to 140 tea, the red bar go up to coffee 70. We'll do the same. So we color differentiate it. You can differentiate it by maybe maybe you use one to be like this, and the next one, that one would be tea, and then the next one is plain. So you use like the lines inside of the bar. It doesn't matter how you differentiate it. Next one, we go up to 180 for tea, and we go up to 80 for coffee. Then we'll go for Wednesday, 150 and 50. Finally, 100 and 100. That's it. Easy. Soft. Now we need to interpret bar charts. So I want you to pause the video and answer these questions. It says a dual bar chart shows information about the number of boys and girls in Mr. Ferguson's extra mathematics classes. Pause the video, answer part A through to D. Okay, let's go ahead and do it now. It says how many boys are in the mathematics class, right? So how many boys are in the mathematics class? Now, to find out how many boys are in the mathematics class, notice that Mr. Ferguson has what? He has math class, he has add math class, and he has pure math class. So, to find out now how many boys are in the math class, we just have to add each. And remember, math is blank, right? So we notice right here is what? 9 boys, because it little over the 8, this is 9 boys, right? We know right here is 18 boys, right here is 14 boys. So many boys all together? 14 and 18 is 32, and 9 is 41. So there are 41 boys in total. Now this one says, which class has more girls than boys? Which class has more girls than boys? So you look at which chart or which bar is bigger. So the CSEC mathematics class, that one have more girls than boys, right? Yes. Now it says, are the are the more boys than girls in Mr. Oh, this should have been, are there more boys than girls in Mr. Ferguson extra classes? So it's asking us a question. Are there more boys than girls? It's a yes or no. How are we going to differentiate that? How are we going to tell that? First thing we need to do is write down how many girls. This is 16. This right here is 8. And this right here is 14. So 16 and 14 is 30. 30 and 8 is 30 and 8 is 38. So notice in total there are what? 38 girls and 41 boys. So are there more boys than girls? Yes. Now it says which extra class has the most number of students? To find out most number of students, we notice 18 and 8 in this class is really 26 students together. In this class, 9 and 6 is 25. And in this class, 14 and 14 is 28. So the pure mathematics class have the most number of students. So in this case, it would be the Cape Pure Math. And that's it. Okay, I know you want one more to do, right? So here's another one. It says the bar chart shows the ages of children in a youth club. Pause the video and answer part A through to D. Okay, let's go. First one, what is the modal age? Now, modal age is what? All we do is we look for which one occurs most frequent. Most frequent is the highest frequency. This one with 8, right? The tally is 8. So the modal age is this right here, 12 years old. Now it says, what is the range of ages? Now range is what? Highest minus the lowest. Now the highest age is 15 minus the lowest age is 10. So 15 minus 10 is 5. 5 years. That's it. Now it says, what fraction of the children are 11? So to find out the fraction, it's how many children are 11 divided by the total. Now, how many children are 11? This right here is 6. That's the frequency. So 6 over the total. Now, the total is, first thing we have to add them all together. This would be 3, 6, 8. Frequency here is 5. Frequency here is 2. Frequency here is 1. This is 3 and 5 is 8. 8 and 8 is 16. 16 and 6 is 22. 22 and 3 is 25. Now 6 over 25, you can go ahead and simplify that. So, 2 into 6, or you can go, well, can it be simplified? Maybe, maybe not. So instead, I just leave it as 6 over 25, right? Because I'm looking and not seeing how we could simplify that, so we leave it there. 6 over 25. Now it says, what percentage of the children are older than 13? Older. Older mean what? Greater than either 14 or 15. So the percentage would be 2 plus 1 is 3, because there are 3 children older than 13, 3 out of 25. And then we know, of course, we have to multiply it by 100. All right, so 3 over 25. All right, sorry guys, it's not writing. I don't know why. Let me try again. 3 out of 25 times 100, and that is 12%. So 12% of the students are older than 13. And that concludes this video on bar chart. All you need to know, you just need to be able to can construct a bar chart and to interpret a bar chart. It is that easy. All right, so I hope this video was beneficial for you. Make sure to just like and to subscribe. Have a blessed day.